properties, the reciprocal property. If two ratios are equal, the reciprocals are equal. So again, we're looking at fractions. Okay, so if you think about it, if the ratios are equal and you flip them over, they're still going to be equal. The cross product is the key to checking. The product of the extremes equals the product of the means. You know, really what we're looking at here when we're talking about cross product. And we can use a simple example. It's equivalent fractions. If I have 2/3 is equal to 4/6. Now I can see if these are equivalent fractions by checking the cross product. So what I do is I take 3 times 4, and that equals 12. And if 12 is equal to 12, then those, that is the cross product right there. Those are equivalent fractions. So that's really what we're taking a look at. Now let's take a look at a real simple example here. And something like 2/3 is equal to 3W. All right, I want to find out what W is. Now I could sit here and say, well, I got 2 and I got 3.5, so I could try to figure out what number I multiplied by 2 and to get to 3 and do the same thing to the 3. But there's a simpler way. You use the cross product rule to solve for W. So you take 2 times W, which is 2W. You take 3 times 3, which is 9. So I have 2W is equal to 9. I divide by 2 on both sides, and basically W is equal to 4.5. Now I can check to see if that's true by taking 2 times 4.5, and that's 9, and taking 3 times 3, and that's 9. So I can always check my work. So when I'm all said and done, 9 is equal to 9 when I use 4.5 in for W. All right, so that's what we're taking a look at when we're solving these ratios and proportions. Now, we're going to use the stuff that we used in our last chapter to solve a lot of these. So we're not going to have a lot of these simple proportions. We're going to use factoring. We're going to use solving quadratics to solve these problems. So let's look at our next example. If I have 10 divided by t is equal to 2t, right, divided by 5. So again, I'm going to cross multiply and divide. And so here I'm going to end up with 2t squared, right, is equal to 50. Well, now I'm going to solve for t. So I'm going to divide by 2, all right, and I get t squared, right, is equal to 25. All right, now, in a problem like this, now I'm going to take the square root, okay, and t is going to be equal, and remember, whenever I take a square root of something, I'm going to get a plus and a minus 5 for my answers. Now, I want to check these. I have this other term up here called extraneous solutions. These are solutions that do not work, which basically means when I substitute 5 and negative 5 in for t here, it should make a true statement. So let's take a look at 5. I got 10 divided by 5. Is that equal to 2 times 5, which is 10, divided by 5? And the answer is yes. So 5 is a solution. Now let's check negative 5. So I do the same thing. I'm going to have 10 divided by a negative 5, which is a negative 2 this time. Is that equal to 2 times a negative 5, which is a negative 10, divided by 5? And the answer is yes. This is a negative 2 is equal to a negative 2. This is 2 is equal to 2. So yes, both 5 and negative 5 make that solution true. All right, let's go on to another page here. Okay, oops, that's not what I wanted to do. Go on to another page. All right. Oops. Ah. Okay, so we'll do 2 more examples. Now again, we got to keep in mind our factoring. In our next example, we're going to have a negative 3 over d is equal to d minus 3 all over 2d. All right. Now again, we got to cross multiply and divide. Okay. So in this case, I end up with d squared minus 3d is equal to a negative 6d. Now, once I get to here, now I'm going to put it in standard form and look to factor. All right, so I got d squared minus 3D plus 6D. So I'm going to have 3D plus 3D is equal to 0. Now again, if you didn't see what I did there, I added 6D to both sides. And again, I can only combine like terms. Now, I have to look to see if I can factor here. Well, I don't have a C term, so I'm not going to want to try to FOIL this. All right, what I'm going to do is I'm going to see, okay, I want to see if I have a greatest common factor of D. So I factor out a D, and I end up with D plus 3 is equal to 0. So again, D times D plus 3 will get me D squared plus 3D. Now I can use my zero product property, and D is equal to 0. D plus 3 is equal to 0, and when I solve this one, D is equal to a negative 3. Now I need to check my solutions. Now the nice thing about 0 when I'm dealing with fractions, anytime I put 0 into a denominator, it's going to make it undefined. So negative 3 divided by 0 is undefined. So this is an extraneous solution. 0 will not make it work. Now let's try negative 3. So I have a negative 3 divided by a negative 3 is equal to negative 3 minus 3, which is going to give me a negative 6, divided by 2 times a negative 3. Alright, so on this side I get 1. Over here I get negative 6 divided by negative 6, which is also 1. So my only solution to this problem is a negative 3. So again, you're going to have to use the information that we learned in Chapter 10, how to factor binomials and trinomials and all sorts of things to solve these problems. Let's look at one more problem here. Let's say I have a negative 2, right, divided by a minus 7 is equal to, all right, we're going to say x over 5. I'm going to change the variable from a to x. So let me get rid of this. Let me get rid of that and make that an x. Okay. All right. So same thing here. I'm going to cross multiply. So what I end up with is x squared minus 7x is equal to a negative 10. Now, standard form is the key. So let's put it into standard. All right, in all cases, we're going to put it in the standard form, set it equal to 0. So I end up with x squared minus 7x is plus 10 is equal to 0. Now, I look back to factor. All right, now I'm going to look to factor. I can set this one up like this because I know I have a positive third term, so I know my signs are going to be the same. Now I look at my factors of 10. 5 and 2 will equal 7, so I put 5 in here. I put 2 in here. Again, I set them both equal to 0. So x minus 5 is equal to 0, and x is 5. And therefore, x minus 2 is equal to 0, and x is therefore 2. So now I need to check to see if 5 and 2 will work. So I have a negative 2 over 5 minus 7. That's a negative 2, so that's going to get me 1. Over here I have 5 over 5. That also gets me 1, so 5 works as a solution. Now let's try 2. I have a negative 2 all over 2 minus 7, which is a negative 5. And then I have 2/5 over here, and that is also true. So both of those are solutions. So again, you're going to be using proportions, and in the process of using proportions, you're going to go back and look at all the stuff we did in Chapter 10 with factoring to solve these proportions.